Greetings to all. Myself Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the semaphores in operating systems. Semaphores, the most robust alternative to simplest mutex is to use the semaphores, which are integer variables for which only the two operations are defined, that is atomic operations are defined, that is the weight and the signal operations. Note that only must the variable changing step, that is s minus minus, that is decremental, and the 8 plus s plus plus, that is semaphores incremental, be indivisible. It is also necessary that for the weight operation, when the test proves false, that there be no interruption before s gets decremented. However, for the busy loop to be interrupted when the test is true, which prevents the system from hanging forever. Here we have the syntax for the weight and the signal operations. First one is weight operation. Here we define the weight s, that is weight semaphores, where while s greater than or equal to 0 and then s minus minus, that is decremental operation is held here. Next one is signal operation. In signal operation, signal s, that is semaphores, s plus plus, that is incremental operation performed here. Next one, semaphore usage. In practice, semaphores can take on one of the two forms, that is binary semaphores can take on one of two values, that is 1 or 0, and then they can be used to solve the critical section problem as described above, and can be used as the mutexes on the systems that do not provide a separate mutex mechanisms. The use of the mutex for this purposes is shown in the given figure. That is, here we have the syntax, that is do waiting mutex, and then the critical section will held here. After finishing the critical section, the signal mutex will happen, and then followed by the signal system call, the reminder section will held on, and then while the condition is true. The semaphores can also be used to synchronize the certain operation between the processes. For example, suppose it is important that process P1 execute the statement S1 before the process P2 execute the statement S2. Here P1 and P2 defines the process 1 and 2, and S1 S2 defines the semaphore statement S1 and S2. First we create a semaphore named the sync, that is the two process, and initialize it to the 0. Next, then in the process P1, we insert the code, that is S1 signal synchronization, and in the process P2, we insert the code wait, that is wait synchronization, that is S2. Because of the synchronization was initialized to 0, the process P2 will block on the wait until after the P1 execute the call to the signal. Next one, semaphore implementation. The big problem with the semaphores are described above is the busy loop in the wait call, which consumes the CPU cycles without doing any useful work. This type of lock is known as a spin lock because the lock just sits there and spins while it waits. While this is generally a bad thing, it does not have an advantages of not invoking the context switches, and so it is sometimes used in the multi-processing systems. When the wait time is expected to be short, one thread spins on one processor while another completes their critical section on the another processor. The new definition of the semaphore and the corresponding weight and the signal operations are shown below. Here the semaphore structures, that is type definition of structure int value. Here the structure processor is list and the semaphore. Next followed by the we have the weight and the signal operations. In weight operations, weight semaphore yes. In weight the value will be the decremental value. So the value given as minus, if s greater than or equal 0, and we have to add this process as s list and then block. For the signal operation, the value must be the incremental value. So the syntax will be signal semaphore yes. Yeah, yes, the value will be the incremental, so value plus plus. If the value of s is greater than or equal to 0, and then it remove the process p from the s, that is a list, and then last one is wake up p, that is process p. Here we have the two atomic operation, that is wait operation and the signal operation. In wait operation, the value must be decremented, and in signal operation, the value must be the incremental. Thank you.